0.75, where humanity stands now. Right now, humanity is here, on this tiny blue dot floating in the vastness of the universe. But if other civilizations exist out there beyond our planet, how can we measure how far they've advanced? And how do we even know where we stand? In 1964, Soviet astrophysicist Nikolai Kardashev proposed a groundbreaking idea, the Kardashev scale. It offered a clear way to classify civilizations based on the energy they can harness. In humanity's early days, we only used the energy from our own muscles. Then came domesticated animals, horses, oxen, which allowed us to tap into stronger power. Later, the steam engine took us into a whole new era, enabling energy use at a scale hundreds of times greater. Today, we consume energy at levels that our ancestors couldn't have imagined. Civilizations need energy to grow. And as they develop, the amount of energy they use increases exponentially. The Kardashev scale measures a civilization's advancement by how much energy it consumes. Originally, it had 3 levels: Type 1, Type 2, and Type 3. Then in 1973, American astronomer Carl Sagan refined the scale, suggesting a formula that allows for precise decimal values to evaluate a civilization's progress. According to that formula, humanity is currently at Type 0.75. We haven't even reached Type 1 yet. A Type 1 civilization is one that can harness all the energy available on its home planet. For us, that would mean completely mastering Earth's energy. To get there, we'd need to increase our energy usage by about 500 times. A Type 1 civilization would use about 10 to the 16th watts of energy. At that point, science fiction becomes reality. They could control the weather, eliminate natural disasters, build massive cities underwater or at sea, and even terraform nearby planets, turning them into livable worlds. The Terrans from StarCraft would be a Type 1 civilization. And experts estimate that humanity might reach this level in the next 100 to 200 years. But there's a catch. The resources we rely on, coal, oil, natural gas, are finite. Once we fully exploit the energy of our home planet, we'll inevitably look to the stars. So what's the easiest way for a Type 1 civilization to access an enormous amount of energy? The answer is right above us: the sun. The star made of plasma unleashing mind-blowing amounts of energy. Our sun, for instance, emits about 38.6 yottawatts, 3.86 times 10 to the power of 24th watts every second. A civilization that can harness all of a star's energy? That's Type 2. Surprisingly, a concept for this already exists. The Dyson sphere, proposed by physicist Freeman Dyson in the 1960s. It's a colossal megastructure that would completely surround a star to collect its energy. Right now, Earth receives only a tiny fraction of the sun's output. But with a Dyson sphere, we could capture every last bit of it. A Type 2 civilization would treat entire celestial bodies as resources. With this energy, they could travel near the speed of light, terraform multiple planets, and expand their civilization across vast star systems. They might develop technologies like warp drives, still within the bounds of physics, allowing them to bend space and surpass light-speed travel. If you can't quite imagine that level of advancement, just picture the Protoss from StarCraft. They shatter planets, command fleets of thousands of starships, and wage wars with armies numbering in the billions. Some theories even suggest they could use black holes to both dispose of waste and generate energy. This is known as the Penrose process, where an object falling into a black hole's ergosphere splits, and one piece is flung outward with added energy. But humanity faces a major problem if we hope to reach this level. Even if we used every terrestrial planet in the solar system, Mercury, Venus, Earth, and Mars, we still wouldn't have enough material to build a Dyson sphere. To solve this, we'd need to strip the atmospheres of gas giants like Jupiter, mine their cores, and even harvest materials from planets beyond our solar system, which demands unimaginable technology and time. Estimates suggest it could take anywhere from 1,000 to over 3,000 years for humanity to get there. Now imagine if a civilization could harness not just one star, but all the stars in its galaxy. That's Type 3. Such a civilization would wield energy on a galactic scale. To reach Type 3, humanity would have to conquer the entire Milky Way. At the center of our galaxy lies a supermassive black hole, about 4 million times the mass of our sun. Adding to that, quasars that shine 700 trillion times brighter than our sun. Gamma-ray bursts that release more energy in seconds than our sun does in its lifetime. And red supergiants like Stephenson 218, which dwarf our sun in volume by billions of times. A Type 3 civilization would use all of these as energy sources. They would manipulate space-time itself, create or destroy stars, shift entire planets at will, and operate at a level so advanced they'd appear godlike to us. In 2011, physicist Michio Kaku proposed Type 4, a civilization that can control the entire universe. At this level, they wouldn't just use energy, they'd manipulate reality itself. They could reverse cause and effect, alter the fundamental laws of nature, and speak entire concepts into existence. Just like the phrase, "let there be light." If a Type 3 civilization is like a gamer using cheat codes, a Type 4 civilization is the developer, creating and rewriting the very game itself. Some even propose Type 5 and Type 6 civilizations, existing under the assumption that multiple universes are real. Type 5 would draw energy from many universes. Type 6 would control all energy across every universe. How long it would take humanity to reach these levels? It's impossible to estimate. The Kardashev scale is built on the absolute laws of thermodynamics, unchangeable truths of our universe. First law: energy can neither be created nor destroyed, only transformed. Second law: every energy transfer increases entropy, a measure of disorder. As we consume more energy, we produce more waste heat. And that's where the scale has some flaws. First, energy efficiency. Take GPUs, for example. The 2017 GTX 1080 Ti used about 250 watts. But the 2023 RTX 4060 uses only 115 watts, yet performs better. By Kardashev's metric, more power equals more advancement. But real progress is often about doing more with less. Second, entropy. As we produce more heat, Earth warms. If we can't solve global warming before we reach Type 1, our civilization could destroy itself before it ever escapes its cradle. Third, cooperation. Massive projects like Dyson spheres require unity, complete global collaboration. Yet humanity still struggles with conflict, division, and fleeting peace. Unless we radically evolve our ethics and mindset, we may never reach Type 2. Despite its flaws, the Kardashev scale remains one of the most intuitive ways to visualize technological progress. Some suggest that to reach the next level, we'll need another revolution like the Industrial Revolution. AI is one candidate. Others suggest humanity may need to abandon biological bodies altogether, uploading consciousness into machines entering a digital civilization. But according to a 2015 study by the Netherlands Institute for Radio Astronomy, Type 3 civilizations may be extremely rare, or even non-existent in the observable universe. So, is humanity truly alone in this vast cosmos? Or is there an advanced civilization out there, so evolved that it views Earth as nothing more than a battery? This was Midnight Journey,